over the last few years, the Internet of Things has evolved from a pure science fiction concept to the reality. Billions of smart devices are getting connected this decade. And the question is how to use this to drive business and innovation. Partially, the answer lies in our capability to tap into vast amounts of data produced by these devices and to be able to quickly analyze this data. To make it possible, the process of data collection and analytics should be fast, reliable, and easy to be able to scale to large deployments from millions and tens of millions of devices. Today we would like to present the solution to the IoT data collection and processing problem that is based purely on the open source platforms, Apache Spark and KaaIoT. Let's review the agenda of today's webinar. We are going to start on discussion about data ingestion challenges that developers face building different solutions that ingest and analyze data from the IoT devices. Then we are going to quickly overview key benefits of KaaIoT and Spark systems and proceed with reference architecture and reference architecture of our sample applications that we are going to build. Finally, we will proceed to hands-on part of our webinar, where we are going to implement sample application that will collect data from Intel Edison and analyze it in Apache Spark. We will cover environment setup, code walkthrough on both Intel Edison application side and on Spark Analytics application side, and we will have a live demo of this application. In the end of our webinar, we will have Q&A section. There are several most important data ingestion challenges that I want to highlight. One of them is, and I believe the most important one, is guaranteed data delivery. In different analytics systems and different solutions, we want to make sure that all data that is generated by devices is delivered to analytics system. It is also important that all solution should be scalable and secure. And I am talking about horizontal scalability. One of the other important items is performance of the solution. So you will probably want that your hardware will be loaded on 100% and would support as much devices as it can. And the other major item is low latency of data delivery. I'm talking about low latency of data delivery from the clients to the analytics systems and low latency in processing of this data. There are several nice to have features that I also want to talk about. This is first of all ability to structure the data that you are pushing to the analytics system and ability to validate the structure on all the way from the clients to the analytics system. There are several, the other important item is to be able to easily port or to be able to deploy your solution to a lot of client platforms like Intel Edison, Raspberry Pi, BeagleBone, or small one like STM32, etc. For the small one, for the small platforms, it is also important to have a low footprint on memory and disk usage. Let's jump to the next slide where we will discuss what KaaIoT is for the people who is not familiar with KaaIoT. So KaaIoT is a middleware platform that allow to connect your hardware sensors and hardware devices to your applications in the cloud. For example, you can collect data and push to analytics systems, or you can update state of the device and configuration push notifications to the devices in the field, and you're also able to enable messaging between these devices using Ka. The key benefits in data collection section of Ka platform is, first of all, guaranteed data delivery. Second of all, support of large amount of devices, because we have C, C++, and Java SDKs that can be is already ported or can be easily ported to your target platform. And well, one of other important items is efficient data serialization mechanism. So by knowing the structure and by defining, user is able to define the structure of the data that he wants to collect, and defining the structure allow us to auto-generate a lot of code on the client side, as it eliminates boilerplate code in serialization and deserialization, and efficiently serialize data to the binary form. I assume a lot of people know about Spark, but for those of you who are not familiar with Apache Spark, I want to say that this is a very performant cluster computing engine that allows to build different applications and different analytics applications very quickly, comparatively, for example, to Hadoop MapReduce. One of the key features that we will use is support of streaming analytics. So this feature allows to analyze data as it arrives to the cluster in near real-time mode. For example, analyze last 5 seconds of analyze data that arrived 5 seconds ago or during 5-second interval. It is also 100% open source, and you can deploy this to various platforms. Like it can be co-located with Cassandra, Apache HBase, Hadoop, and KaaNodes. So let's assume that we want to build a simple sample applications that will monitor performance of the solar power plant. The our plant will be distributed into geolocation zones, and in each zone there will be a certain amount of power panels. And we will be interested in monitoring average power production in each zone. We actually built this solution for one of the exhibitions, and it was collecting data from mini solar panels and pushing this data to real-time dashboard. But in our case, we will do a simple Spark processing, and data visualization is out of the scope. Let's review reference architecture of our solution. So there is an Intel Edison devices in the field that will collect information from solar panels using client application. This information will be raw data, different metrics, etc. Using Ka SDK, client application will transform raw data to structured data and push the structured data to Ka server. Ka cluster, it can be distributed deployment or Sandbox, will use Flume agent and will wrap the structured data in batches in Flume events and will push these Flume events to Spark node for processing. Spark cluster will aggregate data coming from all of the Intel Edison devices. It will map this data by zone IDs and calculate separate statistics for each zone ID. This will be a simple statistics in our case that will just calculate average amount of power produced by each panel. So let's proceed with development environment setup. The first thing I want to say is that we have a GitHub repository with examples, with this application examples that we will use during the demo. And it contains all the code that we will show today. I assume that you already have or you have access to Apache Spark environment. And in my case, I'm using Apache Spark in standalone mode hosted on my local machine. The other things that we want to use is called Sandbox. And let's proceed to kaaproject.org and download the Sandbox. So we can click download Kaa button on the main page, and then click on icon near the Sandbox image file. This will basically start the download of Sandbox file. It is quite big because this is a virtual machine image, so I already have this image pre-installed. I will now start the import of this image. So the only thing that I will change in the appliance settings is amount of CPUs. I will have 2 CPUs in order to make it start a little bit faster. While Sandbox is imported, I want to highlight the documentation page about Kaa Sandbox. This documentation page contains useful information for people who are importing Sandbox. It has 6-minute video tutorial that explains Sandbox deployment in detail. It also have a troubleshooting information and various information about configuration. The most important here is network configuration, because by default Sandbox components are not available to the host network. This means that Intel Edison devices will not be able to connect to your cluster by default. You need to change network configurations a little bit. Let's wait while it is imported and go to settings, check network, and switch network adapter type from NAT to bridged adapter. One more thing that we need to do is to change advanced mode to allow all. And there is one more specific settings to my account, to my network topology and network security. This is specific MAC address, but this is optional step. So let's start the Sandbox. While Sandbox is started, I want to explain a little bit what Kaa Sandbox is. So this is a virtual machine that contains all Kaa components, all Kaa server components pre-installed and pre-configured. It also has a list of sample applications that are available for you to use and for you to get started with Kaa. Let's wait a little bit while application is start up. So the basic interface of the Sandbox is loaded, and now we can navigate to a second screen and use default login, Kaa, in order to get SSH access. We're going to execute if interface config in order to identify our network address where Sandbox is available. So in my case, it is 10.2.3.89. So it is probably, let's check if it is loaded already. Looks like it needs some more time to start up. So as soon as Sandbox is loaded, it prompts you to change KaaHost IP. This is an important step because that is how we will reconfigure the Sandbox in order to publish its external IP address to the client. So let's click the Change Host IP button and specify our IP address. During this step, Kaa services, external services that are used to connect our endpoints like Bootstrap and Operation Server are stopped, reconfigured, and started again. Usually this takes like 20-30 seconds. Now Sandbox is reconfigured and ready to use. As you can see, we have a lot of applications here, and we have sample applications for each feature. In our case, we will use data collection feature. So we will filter out our sample applications by data collection feature and by C++ platform. Let's now download this data collection demo. And we will use this demo in our sample application as a basis for our sample application because it already contains useful build scripts and project structure. Let's now navigate to Administrative Console in order to review what needs to be provisioned on the server side in order for application to work. So let's open the configuration demo and oh, sorry, not configuration, but data collection demo. So applications that use data collection feature require provisioning of log schema. This application already has log schema that is used in sample applications, but we will need to provision log schema specific for our environment. Oh, sorry, for our sample application. This data schema is already available on GitHub, and we will now review it and highlight the main items in this schema. So we have a power report record, which has timestamp and has array of samples, which is also a record power sample. This power sample has three fields, two integer fields, zone ID and panel ID, and the power field, which identifies amount of power generated by each panel and each zone in one of the zones. The important thing to notice that this schema is completely user-defined, and you can change it and experiment with it. So let's now import the schema using our administration UI. There is two ways to provision the schema. First one is by manually typing it in our administration UI schema builder, and second one is uploading from file. We will use a simple way, just uploading from file. So as you can see, this is imported in our administration UI, and we will just name it same as a root record, power record, and click Add button. As you can see, we have a new item in the log schemas list with version 3.0. Now we can go to the main application page and click on Generate SDK button. We are able to generate SDK for different languages, so we will use C++ in this demo. And important thing to check is that log schema version is the most is 3.0, basically matched to the schema that we just provisioned. So we click the Generate SDK button, and we just downloaded an SDK. So now we will unpack data collection demo So we unpacked extracted data collection demo, and now we will replace newly generated SDK with old one. So KaaSDK is in libs folder. So we are pasting new one here, and you can see that in naming there is log version 3, and delete old one. Now we can, the other thing that we need to change in this demo is the source code file located in the source code folder. So it is also available in our repository, and we will first replace it and review a little bit later. So let's now zip this folder and push it to our Intel Edison. Now we can log into our Intel Edison device. And unzip this file. Let's now go into this folder and start the build. You should type build-build in order to start the build. Building C++ application is quite a time-consuming operation, so we can now review the source code of C++ sample application and talk a little bit about environment setup for Intel Edison. Let's start from the review. So the main function contains several constants that specify amount of zone counts and panel count we're going to simulate in this sample application. It also has initialization step, creation of KaaClient and start of this client. It is also important to highlight a log upload strategy. This is basically the interface for user control about how often and how and basically the strategy of the log upload. For example, I want to upload logs when there is at least 10 records, or I want to upload logs as soon as they arrive, or I want to upload logs each 10 minutes, etc. And important thing to notice here is that we have a power sample and power record classes already auto-generated and built and referenced from an SDK. So this power sample record matches absolutely to the record in our JSON schema, and it also has same zone ID, panel ID, and power items. So basically, by using Kaa, you're able to leverage the schema generation and auto generation of the code, and you eliminate all boilerplate and headache related to data serialization and data deserialization. KaaSDK also contains convenient methods like add log record. This is the only method you need to execute in order to push the record to the server. So now let's go to the documentation page of Intel Edison. It is accessible from the main Ka documentation page. You can simply scroll to hardware platforms and click on Intel Edison. And this documentation has a list of third-party components required by Ka and detail installation steps for each component in order to start building applications on Intel Edison. So we have all these components pre-installed in our Intel Edison, so that is why we're able to execute a build. So we're basically done with client-side code review and now can proceed to server-side review. I mean analytics application. So analytics application is a simple Java application that contains two classes. One is a Spark launcher. One is a Spark launcher that contains environment-specific constants that you will need to change in order to deploy application to your Spark cluster. And it only contains Spark launcher that simply launch the second class, which is called KaaSpark example. This application, this class contains the main logic of application. And let's review this Spark Streaming application logic and code. So first of all, I want to show the diagram about Spark Streaming. So Spark Streaming can support a lot of input sources like Kafka, Flume, etc. And in our case, we are using Flume in order to deliver data from Ka system to Spark Streaming. It is able to analyze the data in batches for a specific time interval and push data to different storages or real-time dashboards. In our case, we will have very simple processing that will, and input data will be distributed stream of Spark Flume events. And the distributed stream is specific to Spark data structure that represents a stream of events that are distributed among the cluster. And we will use flat map function in order to map Spark Flume event, decode it, and map it to zone ID and zone statistics. Then we will use reduce by key function in order to aggregate zone statistics, and then we will use sort function in order to sort results by zone ID. We will use simple map function in order to convert results to strings and output them to console. So because we are using Ka, building analytics is especially simple. Ka ensures end-to-end data structure integrity, and because the platform knows the schema of the log data we are collecting from Edison, it is capable to auto-generate object bindings for Spark and automate serialization and deserialization of the data. Once you have configured the log schema, you can go into Ka Web UI and download the data definition library. Let me show you how. In Ka Administration UI, we have a log schemas where we provisioned our schema, and opposite to version 3.0, we have a library button that enables you to download the library. I already have this library imported into my project. As you can see, the classes that are imported are Power Wrapper and Power Sample. They correspond to data definitions in my log schema. And now in the data processing, in the data processing code in Spark, we are able to use zone ID and power and other fields that are very convenient fashion, in a very convenient fashion to do the processing. And these fields matching our log schema provision. So let's start this application. The application is started and it periodically outputs time, and it will do it in each 10 seconds. And if the data is arriving to the application, it will also print statistics about zone, zone statistics about power creation, etc. So one more important thing that we need to do is set up a bridge between Ka server and Spark server, and this bridge is called log appender. So by default, data collection demo is outputting data into MongoDB, and we will remove this appender and provision new one, which we will call Flume appender. As you can see, you can specify minimum and maximum schema versions that will be supported by this appender. So in our case, we don't care about these parameters, but in production deployments, it is very convenient. We also specify confirmed delivery. This means that as soon as data will be written successfully into Flume and will receive confirmation from Flume agent, we will confirm to the client that he can clean up it from his local storage. And that's how we guarantee that data will be delivered and will not be lost. If client receive failure in delivery from one server, it will either retry or switch to another server, but it will keep the data locally and will not lose it until he will receive confirmation that data is delivered. So let's pick Flume type, and we will have prioritized balancing, and we'll specify host where we want to push our data. This is 10.2.2.89, and click Add button. So now we have our Flume appender installed and running, and we also have our Sandbox, our Spark application running. So let's see, we have our client library built, but it will also take some time to build a client application. Meanwhile, maybe someone has any questions while client is built. So we are waiting while our client will complete the build. I mean, Intel Edison will complete compiling our application. So I see someone had questions. Hello? I think that was pressed by accident. Do you have any questions? So you can speak now.
Instead of Apache Spark, can we use Apache Storm?
Yes, you actually can use Apache Storm through Flume or yeah, basically through Flume. And if there will be some need to improve performance or use other way to ingest data into Storm, you can basically build your own implementation of Appender and plug in it to the system. It is quite simple, and we have documentation page on our website how to do this. So that's basically extending few interfaces, and that's it. But you can use Flume to push data there. Or you can push data to some intermediate system like Cassandra and extract it from there. Do you have any other questions?
I think there's another question from Jayanta. You can speak now. Hello, you can speak now.
Okay. So instead of Intel Edison, can we use as
Sorry?
instead of Intel Edison, which is not available at our place, can you use Raspberry Pi device?
Yes, you can use Raspberry Pi with either C++ or Java SDK, so whatever is convenient to you. It is also, it is also Linux operation system, so the same instructions are applicable.
I think we have another question from Surendra.
Let's check if our client complete the build. Yeah, client completed the build, so now we can go to the, let me check, to the build folder and start the demo client. Once it's started, we should see statistics arriving here in Spark in a few seconds. Here we can now see that average power produced by panel, by different panel is different. So this is random generated code. So I mean random generated values. So they are almost equal. Okay, so let's get back to the slides. So now you can see how we, under 300 lines of code, we can build a solution for data telemetry from IoT devices and also process this data in real time or near real time via Spark. KaaIoT Spark architecture basically allows us to scale the system to handle tremendous workloads and to be very reliable. This is it for today. We will send over you all the resources and links in the next 24 hours so that you can try and experiment with this code yourself. There is a good chance that you will be the first users of the new Kaa release that was made publicly available, 071. Thank you for your attention and looking forward to welcoming you in Kaa community. Are there any questions in the meanwhile?
Yeah, actually there was a question about if we can use Kafka instead of Flume. The question from Surendra.
Oh, okay. So basically this will, Kafka Appender is now not available in Kaa. but it is in our roadmap, so maybe it will become available in 0.80 release. Or, as I already said, it is quite easy to implement on and contribute to support of Kafka appender. Welcome.
Yeah, and another question from Vigia Panalo, sorry for misspelling. How about Apache Storm instead of Apache Spark?
So that was, we already said this.
Okay.
So I think there is no questions from the audience, right? Thank you very much for your time and attention. Bye.